this is Vandana and you are watching 99.9 Engineering Station. So student, today I am going to solve a numerical on transport phenomena which is asked by my US student. So basically he want me a personal help for solving the number of numericals, okay. But after some time I realized that if I send him the solution of the question personally, then how can I help my Indian student? So I dropped the idea of sending solution personally, rather I make a separate video on it so that everybody take advantage of it. So let's start with the numerical, but before that, if you have not subscribed to my channel, subscribe it, otherwise you will not get any type of notification from my side. And one more important thing is that you have to follow me on Telegram, because in Telegram I used to post many important questions, numerical, short notes and many more things. So follow me there and subscribe my YouTube channel. So the student, the question is from the topic volume flow rate through the annulus, okay, and the question is an horizontal annulus 27 feet in length and has an inner radius of 0.49 inch, okay, and the another radius of 1.1 inch. A 60% aqueous solution of sucrose is to be pumped through the annulus at 20 degrees centigrade. At this temperature, the density is 80.3 lbm per feet cube and the viscosity is 136.8 lbm per feet hours, okay. We have to calculate the volume flow rate when the impulse pressure difference is 5.39 psi or 5.39 lbf per inch square, okay. So we have to calculate the volume flow rate, and the given data we have that this is the inner radius, this is the another outer radius, okay. This is outer radius, 60%, this is the amount of the sucrose, 60% of sucrose, and the also we have given that the temperature, that is 20 degrees centigrade. Also we have a given data of density and viscosity, but all the data is given in the form of FPS system. So we have to convert it into a SI unit, okay. So first we have to convert it into a SI unit for putting into the main formula for calculating the volume flow rate, okay. So student, if you see this topic in your transport phenomena book, that is in bird, you can see that by this topic you will be able to calculate the maximum velocity, average velocity, volume flow rate, mass flow rate and force exerted by the fluid. I will be display here the whole formula of calculating the various thing, okay. So in this portion of the question we only have to calculate what volume flow rate at a particular pressure difference, that is 5.39 psi, okay. So let's start the numerical by solving it. So student, basically we are going to solve the volumetric flow rate through the mass flow rate. For that we can write W is equal to dm by dt. This is the mass flow rate, and we replace the m by d rho v by dt. If the density is constant, we remove the density from the differential part, and we then the exact term which get from this equation is rho dv by dt. Now we are going to divide the whole equation by rho in both sides. Then what we get? We definitely get the dv by dt is equal to 1 upon rho dm by dt, okay. And from the above equation we replace dm by dt by w. So this equation become w by rho. So from here we get the equation, that is dv by dt is equal to w by rho, okay. So this is the main concept which we are going to use in the numerical, okay. So student, formula for calculating the mass flow rate in the annulus is W is equal to pi P naught minus P L R to power 4 rho upon 8 mu L bracket, inside the bracket 1 minus k to power 4 minus 1 minus k to power 2 to whole to power square upon ln 1 upon k. So basically here omega is the mass flow rate, this P is represented by basically abbreviation for the term, that is P is equal to rho g h. This P is the abbreviation for the term P minus rho g h. Okay, so here the K term is the ratio of inner to the outer radius. Okay, now this is the formula for calculating the mass flow rate. Now this formula we put it into the previous equation, that is dV, what we get in the previous equation, dV by dt is equal to omega upon rho. So we put the value of W in this equation, then we get the final equation, that is dV by dt is equal to pi P naught minus PL upon 8 mu L R to power 4. This rho is cut by the denominator rho and the whole term is same. So the equation for calculating the volumetric flow rate will become this one, the final equation, the equation which is going to solve by putting this parameter. Okay, so now you can see that the all the parameter is given into a FPS system. Now we have to convert into a SI unit. So for pressure, you can see that the pressure, the given parameter is that 5.39 lb fit per inch. So we convert lb fit into a Pascal by simply multiplying it by the 6.8947 into 10 to power 3 Pascal. So this lbf per inch, cut it down by this lbf per inch, and after multiplying the whole term we get the pressure in Pascal form, that is 3.72 into 10 to power 4 Pascal. That is the SI unit of the pressure. Okay, now the another parameter is viscosity, which is given in 136.8 lbm fit per hour. Okay, so we convert this term, this FPS system, into the Pascal second. Okay, so we simply multiply the term with 4.1338 into 10 to power minus 4, and after multiplying all the term and cancel out the same unit, we get the viscosity as 0.5655 Pascal. Okay, the next parameter is length, that is we get 27 feet. Okay, in the question we have the length is 27 feet. We convert this length into a meter by simply putting the conversion factor for meter and feet. And similarly, we put the value of radius in inch, given the parameter is in inch, and we convert into a meter, and the final radius of the question become annulus portion is 0.28 meter. Now we are going to put all the parameter in this equation, the main equation which we get from the by dividing the rho omega W by rho. Okay, now we have to calculate the dimensionless parameter, which is K, and this is K value is the ratio of the inner to outer radius. Okay, so simply we divide the inner radius to outer radius, then we get 0.45 the value of K, which is dimensionless. Now we are going to put all the parameters which we convert into a SI unit into a main equation. So after putting all the values in the equation, we finally got the answer like that is 0.0031 meter square per second. So this equation, this answer in the SI unit. Now we have to convert into again to the FPS system, that is we convert 1 meter is equal to 3.28 feet, and we simply cube it. Okay, so finally we get the equation, that is the 0.110 feet cube per second. This is the main answer, that is our volumetric flow rate. ठीक है, all right. So that's how you solve this type of question. That is very simple, only formula based. The most important thing is that you have to memorize the formula of the each and every topic very carefully. So you can see that this numerical is totally depends upon the formula and nothing else. So you have to memorize the formula very carefully and then unit conversion also. Okay, so next time I will be back with another numerical which is asked by the US student. So till then, thank you and have a nice day.